S-Chan presents educational video lectures. Difficult concepts made easy. Study anywhere, anytime.
So what is the motion of particle like electrons when they are moving in the solids, liquids and gases? So in order to describe the motion of particle in the liquids, gases and solids, some theories are given. In that case, that theories can be classically in which the particle motion is get trapped, quantum mechanical motion is there, and the John theory is behind that. So all these theories that are summarized in the one theory, that is a free electron theory, which is used to describe the motion of particle in the gases, solids and liquids.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
So welcome to S-Chan Academy. Myself Dr. Narendra Kaur. Now I will explain what is the motion of particle when they are moving in the solids, liquids and gases. So that theory is given as the free electron theory. So we know that basically the material that can be solids, liquid or the gases in the gases form. So in solid we know that the motion of the particle, we understood that the particle that cannot move freely. So what does it mean? So if there are the three boxes are available over there, so one is a solid, liquid and in the gases form. So material means the things which are placed over here. One is the solid form, liquid form and the gases form. We know that in the solids the particles are not move freely. What does it mean? That means atoms in the solids, they are closely packed to each other. So atoms are closely packed to each other. When atoms are packed very closely to each other, so it is very difficult for the electrons to move from one end to the another end. So that's why the particles are not able to move in the solids. While in the liquids we know that the particles, they are packed to each other, not very close to each other, and they are loosely packed. So that's why the electrons, they can move from one end to the another end by suffering multiple diffraction or the multiple reflections from the each and every atoms which are present on the liquids. And the number of atoms per unit volume, that is small, that is within the given range. So that means the number of atoms are small but they are not very large. So in this case the atoms or the particles, they can move but they cannot move freely. While in the gases we know that gases, they are very easy to move. So atoms or the particles in the gases or the electrons, they can move from one end to the another end freely. So free electron theory is basically describe the motion of the electrons and the particles in the gases here. So how their motion that is possible. So that means we know that in the solids, electrons in the outermost orbit of atoms, they will determine the electrical properties. Electron theory is able to applicable to all the solids, both metals and non-metals. So we know that in solid, if atoms are very closely packed to each other, so that means electrons in the outermost orbit. So in the atom that is made up by the solid, if there is atom over here, then electron in the outermost orbit, so that is freely, it can freely move from one end to the another end. Now if the electron can move freely from one end to the another end, so that means they are known as good conductor of electricity. So that's why we can describe the electrical properties of the material depending upon the motion of the electrons. So these are the electrical properties. That means we can see that type of solid that can be good conductor of electricity. So electricity that can be evenly conducted in a good manner. So that theory is applicable over the solid, and such kind of materials are known as metals. While in some cases there are no free electrons and electrons are not able to freely from one end to the another end. So if electrons are not able to move freely, that means the conduction of electricity is not possible. So that means the material that can be non-metals. Non-metals means they can be either in the semiconductor form or they are insulator over here. So that it will explain the electrical, thermal and magnetic properties of the solid. So that means depending upon the structural properties of the solid, we can describe structural properties, magnetic properties, electrical and thermal properties of the solids that can be described by the electronic structure of the atoms which are present over there. Electronic structure means whether the electrons are loosely held or whether they are closely packed. So depending upon that, all these properties of the materials that can be described. So this is known by or explained in terms of electron theory of solids. So electron theory of solids, it can be developed in the three main stages over here. One is a classical free electron theory, second one is a quantum free electron theory, and third one is a zone theory over here. Now, what is a classical free electron theory? The classical free electron theory is this theory is firstly developed by the Drude and the Lorentz. So the basic concept behind is that according to this theory, it is considered that the metals contain free electrons which is responsible for the electrical conductivity, and electrons obeys the laws of classical mechanics. So what are the laws of the classical mechanics means? When the electrons can move freely from one end to the another end, that materials are known as metals and they are taken as good conductor of electricity. Then next there comes a quantum theory of electron, so which is given by the Summerfield, according to which the free electrons they move with the constant potential, and this theory is obviously quantum laws. So classically it is seen that it is not able by the particle to jump the potential box. It will remain entitled to that box only when potential is applied. So classical means it is very difficult for the electrons to jump to the stairs or to jump from one end to the another end. But quantum mechanically there is a existence of tunnel effect. So by that, when the we know that the particle is not able to move, but the waves are associated with the particle. So that waves are known as matter wave. If the particle is not able to move from or not able to tunnel the potential barrier, in that case the waves can move. So this is a quantum laws. The next there is a zone theory, according to which the Bloch introduced a band theory. According to this theory, free electrons can move in the periodic potential which are provided by the lattice, and this theory is also called the band theory of solids. So what does it mean, band theory of solids? So classically theory, it is explained that now there comes the three theories. So one is a classical theory, second was the quantum mechanical theory, and third one is a zone theory. These three theories are developed over here in order to explain the motion of the electrons which are present in the solid. So classically it is seen that particle can move only in this box. It will remain trapped when the potential is applied in this over here, or when the potential is not applied to the solid. When the electrons can move freely, that materials are known as good conductor of electricity, or they are known as metals. When it is not able to move, in that case the material or the when the electrons are fixed to the atoms or the materials, so they are not able to move, that is known as insulators or the semiconductor. So classically it is seen that the particle will get trapped in the potential box. The particle will trapped only, it will remain only in this box. When the potential is applied to the given particle or the given solid, so it is not able to get moved. Quantum mechanical, it is seen that when the particle is placed in this box, we know that it is not able by the particle to jump this wall, but the waves which are associated with the particles, they can tunnel. So according to this, if this is a wave which is associated with a particle and this is a boundary over here, from the boundary the waves can tunnel. So tunneling effect will be present over here. So according to which there must be a tunneling effect. So tunneling effect will be present over here. That means from this boundary condition, the particle that can be tunnel in the form of wave. So that means the waves, the matter waves, which are associated with the moving particle, and the potential is applied to this particle. So instead of particle cannot tunnel, but the wave associated with the particle that can tunnel over here. Second, next is the Jones theory. According to Jones theory, it is seen that the periodic potential that is continuously applied to the particle, and the particle is able to move inside this square potential well. So this is known as square potential well, which is a periodic potential. So potential, it can be taken as positive and negative, continuously it is changing, and that theory is given in terms of Bloch, and which theorem is given as a Bloch theorem, by which motion of the particle that is described in the periodic way. So according to Jones theory, it is seen that the periodic potential which is provided by the lattice, because we know that there are the large number of atoms which are tightly bound in the system. So there in the, if there we are taken in the solid, so in the solid there are large number of atoms which are closely packed to each other. So due to this, the constant potential is given by each and every atom. So there will be the square well potential formed over here. So due to this movement of the electron or the particle, that will be considered in the square well potential with the periodic values, because all the atoms will give the same potential to the electrons or the particle which can move freely inside this box. So this is the Bloch theorem over here. That is a Jones theory. So classical theory which is used to explain the motion of the particle in the solid. So that means we are able to explain, classically it is seen that, so if this material that is composed by different kind of atoms over here, now these atoms are closely packed inside the box, and there is a one electrons which want to move from one end to another end. Now how this electron can suffer the different kind of motions when it has to move in the solid from one end to the another end. Now we know that in the atom there are the positive nucleus inside and electrons are surrounded outside. So that means now this electron will suffer attractive force from this nucleus as well as repulsion force from this electron. So when electrons move from one end to another end, it will suffer multiple reflections in terms of attraction and repulsion. So due to these multiple reflection by all these atoms, electron can able to move from one end to another end. So when the some potential is applied, for example, if we are applying positive potential to this end and negative potential to this end, so electron is easily get attracted by this positive potential. So again it can be moved freely from one end to another end, while without potential it is not easy by the electron to move from one end to the another end. So now let us take a short break. So till now we have understood what is the motion of the particle inside the box, and classically how we can explain the motion of the particle, and it is not easy by the particle to tunnel from one end to the another end. While quantum mechanically it is seen that particles can tunnel in the form of waves, and in the Bloch theorem it is considered that in the Jones theory the particle is suffering the periodic potential.
Now, quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Now before break we understood what are the different kind of theories and which are given in order to explain the motion of the particles or the electrons in the solids. Now I will explain you what is the conceptual wise what is a free electron theory or the classical theory of metals, how we can describe the motion of the particles. So let us begin this classical theory of metals, and how the metals are taken as either they are can taken as a conductor metals or the non-metals. So depending upon that theory or depending upon the classical laws of mechanics, we are able to explain the classical free electron theory of the metals. So classically it is seen that, so what are the basically assumptions behind this theory? So first assumption is that in metal there are many free electrons moving freely in all possible directions. So that means it is considered that in metals there are large number of electrons are present and they are able to move in the random directions, in all possible directions. These electrons behave like as gas molecules in a container which are obeying the laws of kinetics theory of gases. Means in this case it is considered that free electrons are same like that of gas molecules because they can move anywhere in the random direction. Then in the absence of field, the energy associated with each electron at the given point is given by kT value, and it is related to kinetic energy of the particle, which is equals to mv square, and v, what is vth, that is the thermal velocity of the electron, with k is a Boltzmann constant. So then fourth assumption is that in metals the positive ion cores are fixed, they are at the fixed positions, and the free electrons they can move randomly, and these atoms and the positive cores or the other free electrons, they are having the random collisions with each other also, hence these collisions are elastic, therefore electric conduction is due to free electrons only. Fifth one, the electron velocity in the metals, they will obey the Maxwell-Boltzmann distribution of laws, and this velocity is known as the drift velocity. So now what are these assumptions? So according to these assumptions, it is explained like this. So classically it is considered that, now if this is a solid, we know that in solid, so there are different kind of atoms are present. Large number of atoms are present, means when we are taking 1 mole of solid, so 1 mole of solid means there are these atoms number will be 6 into 2 10^23 atoms will be present in the 1 mole of solid. So these atoms will be present. Now atom can be represented as nucleus and electrons are revolving around this nucleus. So these are the electrons. So the large number of positive ions will be present, same number of free electrons will be present. Now we know that these electrons are bounded to the nucleus, but in the classical theory it is assumed that these electrons are not bounded to the nucleus, they can move freely. So this electron is not bounded to this nucleus, it can move freely from this end to this end or this end to this end. These electrons can move in the random direction. So if this electron can move randomly, again this electron is also free, so it can move randomly from this end to this end with the multiple reflections from the another particles. So multiple these electrons will collide with each other also. So if this electron can move freely, so this system is similar to the large number of particles. That means this system is similar to large number of particles or the molecules like gas. So there are a large number of gas molecules which are present in a box. So these electrons are just similar to the gas molecules which are fitted into a given box. We know that gas molecules that can move random from here to here. Similarly, in a similar way, electrons can move randomly from one point to the another point. Now, this is a first assumption. And secondly, it is assumed that when electrons move from one end to the another end, so that means when these electrons are present over here, now there are the large number of electrons are present. So these are the electrons with a negative sign. So large number of electrons are present in the given box. When this electron move from here to this end. Mean if it move from end A to end B, nucleus is also present over here. It will suffer attractive force and repulsive force also. So that means when it suffer attractive force, so there must occur the collisions. So collisions must be there. So these collisions are known as elastic collisions. So that means now elastic collisions are there. So these collisions are due to positive attractive force and negative. These are the repulsive forces also there. So that means due to elastic collision, energy of the moving particle, that means electrons, that will always remains conserved. So energy can never be destroyed or can never be formed in this case. Means in the attractive force, if the electron lose some of its energy, in the repulsive force, it will gain that energy. So that means energy of this, if we are considering here the single electron only, then this single electron will have its conserved energy. Means initially if this electron has energy E, and after suffering all the multiple reflection, and when it reach from one end to another end, its energy will remain intact, that is E, because in the elastic collisions energy is remains conserved. So electron will suffer multiple reflections and the multiple collisions over here. So it can have the positive force, repulsive force, attractive force also. So due to that, it can move freely from one end to the another end, because the collisions are elastic and its energy and momentum that will remain intact in this case. So now when the electron is moving from this end to this end, so this particle, it will suffer multiple reflection. Multiple reflections must be there, and velocity of it, that will be get changed. So the velocity which is, but if this is a particle and it can move freely from one end to another end, velocity of one particle, that can be described as a, this equals to vector sum of all the component. Vector sum of all the components. So in somehow, if this is taken as positive, then that will be negative, and positive, negative, positive and negative. So by taking the vector sum of all the component, the total or the final velocity of the particle, the electrons which is moving over here, that is taken is equals to Vd. Vd is taken term defined over here, that is known as a drift velocity. So drift velocity, that is known as a final velocity of the electron after suffering the multiple reflection, and when it get moved from one end to the another end. So this velocity is known as a drift velocity. So these are the basic assumptions which are considered in order to explain the motion of the particle inside the solids. So then there are some merits and demerits of the classical free mechanics theory also. So what are the merits and demerits over here? Okay. Now when the particle is suffers the multiple reflections and it can move freely, and also the energy collisions are elastic, so the energy will be remains conserved, then it will obviously Ohm's law, energy Ohm's law. So depending upon that, that means energy of the particle that will remain constant. So by depending, when the particle is moving, so electrons are moving, so that means the current must be flowing over there. So in that case, V, that is given by V equals to IR. So when the potential is applied V over here, then the current is flowing in the solid, because when the electrons are moving freely, the material is said to be metal or the good conductor of electricity. So in that case, they will obey the Ohm's law. And it will explain again, that will explain the electrical and thermal conductivity of the metals also. Because we know that in metals, as soon as the potential is applied, they will, or without potential, there will be the existence of current. So current will be there. So metals are basically known as zero potential conductors. So that's why due to this free motion, the electrical and the thermal conductivity, that can be also explained. What is the meaning of thermal conductivity? So thermal conductivity means due to presence of drift velocity in the metal. So this is the term, there comes the thermal conductivity. Then also the Widman's-Franz law is also present over there, which is used in order to calculate the drift velocity of the electrons, and also optical properties of the material that can be calculated over here. But there are some demerits also. Demerits means we are considering here the particle is moving freely from one end to another end. But in insulators and semiconductors, that is not possible, because depending upon the assumption of the metal, classical electron theory, it can only applicable to the metals. But we know that the materials, they are distinguished into three terms. They can be metals or the semiconductors also. So this theory fails to explain the semiconductor and the insulator. Second one, it fails to explain the temperature variation of the thermal conductivity at low temperature. Means at the low temperature, we are able to explain the thermal conductivity of metal. But as soon as the temperature is increased, if we assume according to classical theory, when the temperature is increased, the thermal agitation of the electrons, that will increase. That means its motion will increase. So for the metals, its conductivity must be increased with respect to temperature, but this is not so. The case will be opposite. So that theory, that is not explained by this theory. And also specific heat of the metals, that cannot be explained. And this theory fails to explain the mean free path of the electrons, because electrons are not able to move freely. So mean free path of the electrons, that cannot be explained. Next is a phenomena like photoelectric effect, Compton effect, black body radiations. They are not be explained by the classical theory of metals. So they can be explained by taking the quantum mechanics. So according to quantum mechanics, it is seen that instead of particle, the waves are also associated with the particle. So the light is taken as a wave also. So these phenomena, that can be explained by using the quantum theory. Next, it also fails to explain the temperature dependence of paramagnetic susceptibility and ferromagnetism. Because paramagnetic susceptibility means as the temperature is increased for the paramagnetic materials, we know that their magnetic properties, they are get altered. And also for the ferromagnetic materials, their susceptibility is very much positive, and it does not depend upon the temperature. So this classical theory fails to explain all these phenomena. So this is all about the free electron theory of metals. So classically, it is we are able to explain what is the motion of the particle when they move freely from one end to the another end in case of metals only. While the semiconductors and for insulators, there comes classical quantum theory of metals, and for the periodic motion of the particle, there comes the Bloch theorem. Thank you.
If you want to study this topic in detail, refer to the book by Electron Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.